Hi, I'm Colin. In this module, we're going to factorize the expression x squared plus 5x plus 6. This expression is an example of what we call a quadratic expression, because we have the variable x that's being squared. And that's the highest power of x. Indeed, we don't have any x to the power of 3 or x to the power of 4 or so on. The highest power of x is just 2. Alright, our goal here is to factorize this expression into the following form. That is, the product of two factors, x plus a and x plus b, where a and b are constants yet to be determined. The form on the right hand side is said to be factorized, while the form on the left hand side is said to be expanded. Now, how do you find the constants a and b? Here's what you do. It's actually a little bit tricky. You have to first choose a and b so that when you multiply them together, you get the constant term 6. And at the same time, when you add them together, you get the middle coefficient, 5. Solving this little puzzle is somewhat a process of trial and error, but you become quicker at it with more practice. Okay, so what are two numbers whose product is 6, but their sum is 5? Well, we can focus on just one condition at a time. For example, we know that the product of 1 and 6 gives us 6. But does the sum of 1 and 6 give us 5, the middle coefficient? Well, no, it gives us 7. So this combination of a and b doesn't work. Let's try another combination. We know that the product of 2 and 3 gives us 6. Does the sum of 2 and 3 give us 5? Yes, it does. So this combination works. Hooray! Thus, two numbers whose product is 6 but their sum is 5 will be the numbers 2 and 3. So we can set one of the constants to be 2 and the other one to be 3. Thus, we can factorize our original quadratic, x squared plus 5x plus 6, into the product of two linear factors, x plus 2 times x plus 3. It's important to note that this method of guessing the two numbers a and b only works when the x squared term is by itself. That is, when the leading coefficient is just 1. If we had something like, for instance, 3 times x squared, we would need to use a more advanced method to factorize. Finally, let's finish off by investigating why this method actually works. To do that, we'll need to backtrack a little bit. Expanding the brackets, we get the following. X times x, which is x squared, plus x times b, which is bx, plus a times x, which is ax, and finally plus a times b, which is just ab. Now the two terms in the middle are like terms, and we can collect them together by factoring out the x. Now carefully observe these two quadratics. Since we're forcing them to be equal, their respective coefficients must be equal. So that means the coefficients of x must be equal, and the constant terms must be equal. This precisely gives us the conditions on a and b that we claimed earlier. That is, the product of a and b must be 6, and at the same time this sum has to be 5. Alright, be sure to watch the follow-up to this module, where we use this factorization technique to solve quadratic equations. These equations are one of the most common types of equations that you'll encounter in your study of the mathematical sciences. See you next time.